Let's look at this system. It contains two equations which I will label equation 1 and equation 2. When using the substitution method, the first step is to isolate a variable in one of the equations. You should try to choose the variable that is easiest to isolate. In most cases, this will be a variable that appears to have no number in front of it, but the coefficient or number in front is actually 1 or -1 depending on the sign. Looking at these variables, the variable that seems easiest to isolate in this system is the x in equation 2. So I will isolate x in equation 2. So equation 2, x plus 2y equals 2. In order to isolate the x, I need to get rid of the plus 2y using inverse operations. The inverse of adding 2y is subtracting 2y. To keep the equation balanced, I must also subtract 2y from the other side. This leaves me with x equals 2 minus 2y. This equation is going to be important. I'm going to come back to that later, so I'm going to label that equation, equation 3. I now have an expression for what x is equal to. I can substitute this expression in for x in equation 1. Substitute. Hence, this is where the substitution method gets its name. Substitute x equals 2 minus 2y into equation 1. Equation 1 is 3x plus 4y equals -4. So I can replace the x with 2 minus 2y. I now have an equation in one variable, so I can solve that variable to determine what the value of y would be. I use the distributive property to multiply the 3 and through. 3 times 2 is 6. 3 times minus 2y is minus 6y. Now I combine like terms. Minus 6y plus 4y is minus 2y. I continue to solve this equation using inverse operations for y. To get rid of the 6, I must subtract 6. So I subtract 6 from both sides, leaving me with -2y equals -4 minus 6 is minus 10. I now divide both sides by -2, and y is going to equal -10 divided by -2, which is +5. This is the y-coordinate of my solution. I now need to determine the x-coordinate of my solution. I can go back to equation 3 because I know x equals 2 take away 2 times y, and I know what the value of y is. So I can substitute y equals 5 into equation 3. I could have substituted into either one of those equations. It's just easier to substitute it into this equation because x is already isolated. So x equals 2 minus 2y. X equals 2 minus 2 times the value of y. The value of y is 5. X equals 2 minus 2 times 5 is 10. And 2 minus 10 is minus 8. So I now have the x-coordinate for the point that is the solution to this graph. So my solution is -8, +5. Remember, the first coordinate is x, the second coordinate is y.